Using joins is a refinement of Cartesian product. We have two tables here. The first one is small occupied by with two columns, patient ID and ward number. We have the second table, small ward. The titles are ward number, ward name and number of beds. Using the hospital database, run the following query. So let us see what is the result of this. If you run this query, what will be the result of this? Let us run this query. So we have connected to the hospital database. So let me run the query. The query states select star from small occupied by comma small ward. So let us see the result of this one. You are able to see for the two repeating duplicate columns like patient ID, ward number and ward name and number of beds. So actually this is showing the Cartesian product. The Cartesian product, this is the result of this queries. So modify the Cartesian product query so that the result lists the patients together with the number and name of the ward that he or she occupies. So our idea is to see the patients along with their the name and the number of wards where they are admitted. Okay, so let us run this query and see select patient ID, comma, small ward number and ward name from small occupied by comma small ward, and we are giving a condition here using the where clause where small occupied by dot ward number is equal to small ward dot ward number. So whenever there is an equal ward number in both the tables, if that condition is satisfying, you will be able to see the result. Let us run this query and see the result. So you can see only 3 rows and you can see the patient ID along with the ward number and the ward name where they are admitted or where they occupy. Join query result is the 3 rows we have seen. This the logical processing. The initial table, specified table, from the initial specified table, from the from close, create an intermediate table, from all the tables specified in the from close, and it will create the first intermediate table, and after from the first intermediate table, the where condition, it is checking whether the condition satisfies or not. Once if it is satisfied, it will create the second intermediate table. So from the second intermediate table, so it will extract the data what you are looking for. In this example, you are looking for the patient ID and the ward number and the ward name where they occupy. So if the distinct operator is used in the select clause, each copy row is ignored if it already appear in the final table. Thus we have the final table here. Now let us see how to join more than 2 tables. Any number of relations can be specified in the from clause. So we have seen in the previous example, we have joined the previous example we have seen we were joining 2 tables together. So first one is the small occupied by and the second one is the small ward. So let us see how can we join more than 2 tables. So each join is represented by an equality condition in the where clause. So you have to make sure that you are giving the corresponding equality condition in the where clause to make sure to give. So like for example, you can have more than one condition using an AND operator here. See enrollment.student ID and assignment.student ID. So it is checking whether enrollment ID and student ID both are having the same student ID, and even the and we have second condition here, enrollment.course code is equal to assignment.course code. So it is checking that both enrollment table and assignment table they both are having the same course code. Aliases and self-joins, alternative name for tables. We can use another name for simple use. Rather than writing the entered name of the table, we can always use an alias to represent a table. There are two advantages of using aliases. First, number one, some queries can be made more readable by renaming the table in the from clause with an alias. Readability, increase the readability, number one. Point number two, queries which involve joining a table to itself, called self-joins, are only possible with the use of aliases. If you want to use the same table to be joined alone, such as a recursive relationship, so you can use only, this is possible only with the use of an alias. We have an exercise here, exercise 2.20. Using the university database, write and run a query that does not use aliases to list the name and address for each student and their tutor. See, the question is asking for you to list the name and address of each student. Means you have to display the name of the student and address of the student, as well as name of the tutor and address of the tutor. So without the alias, let us run this query without an alias. So we're going to join three tables here. First one is the student table, second one is the staff table, and the tutors table. We know that in the tutors table you are able to get only the staff ID, and in order to receive the student name and the address, you have to use the student table. So in order to receive the staff address and the name, you must use the table called staff table. So select student dot name, because we can see both the columns are, we can go to the Sybase Central and let us see how they are created, these two tables. Let us start the Sybase Central. Go to your m359 folder and Sybase Central. Connect to, go to, press F11. Connect to the university database. You can see here. So we have the student table here. The student table, we have the student ID, name, address, email address, registration date, and the region number. Let us see the tutor table. Tutors table, you are able to see the student ID, course code, and the staff number. So if you use the, only the tutors table, you will be able to get only the student ID and the staff number. And in order to receive the staff details such as staff name and address, you must go to the table staff. So here you can see it has all the details of a staff number, name, address, email address, telephone, and the region number. Let me come back here. So you can see that's the reason we are using all these three tables. And we have seen here in the Sybase Central that, see, in the staff table, you can see it says name and address. Even when you go to the student table, you're able to see the same titles, name and address. So in order to specify this name belongs to the student table, you have to specify student dot name, and the same thing with the address. So student dot address. Here you can see that this name is from the staff table and this address is from the staff table. So we are selecting the three different tables. And again, the condition, as I told you before, you have to specify the equality condition in the where clause. So the first equality condition is student dot student ID should be equal to tutors dot student ID, because the tutor who is responsible for the student, for example. And the second equality condition is the staff dot staff number is equal to tutors dot staff number. So then make sure that the staff is a tutor. So we have two equality condition and we are connecting three different tables using just here you are able to see the result. So you can see the name of the first column name is the student name, and you can see the address of student. Here you can see name of the staff and the address. So in order not to confuse, you can rename, like for example here you can use an as operator. You can rename the student dot name to student name, student address, staff, tutor name, and tutor address, which is possible. Now let us see the use of an alias. The same query is written. So rather than writing the complete name of the table in the select clause and even the equality condition in the where clause, you can always use any alias. So for example, S1 is used to represent a student, S2 is used to represent the staff, and T is used to represent the tutor. So let me run this query here. So I'm running the query with an alias. Here you are able to see here, see student S1, staff S2, tutors T, and where the conditions are S1 students. S1 stands for student and student ID, T stands for the tutor, S2 stands for the staff, and T stands for staff number. So you're going to get the same result here. You can run a query with an alias or without an alias. Another exercise you can see here, a supermarket database contains a table called floor staff with columns, staff number, name, and supervisor number, all character strings. Formulate a query to find the name of the supervisor of the member of the floor staff who has staff number 345. So here you are using a self-join process, this joining the same table to the itself. So here you can see we have only one table. The table name is the floor staff. So we are renaming first, see the first one, the same table, but we assume that there are two tables, like a virtual table. You can see floor staff F1, floor staff F2. We created two aliases. Now we are getting the name from the first one, F1 dot name. So the condition, equality conditions are F1 dot staff number is equal to F2 dot supervisor number. Actually, we are using the same table, but we wanted to make sure the supervisor number and the staff number are the same. So the question says that a name of the supervisor of the member of the floor staff who has staff number 345. So we wanted to know that this staff number is 345 and it's a supervisor. So you can see here, and F2 dot staff number should be equal to what? 345. So aliases are used in self-join. Now we have inner join here. The join seen so far is called inner join. Inner join does not display tuples from either side of the join unless they actually match. So we give a condition in the where clause. If the equality condition matches, only we are able to see the result. In inner join, rows that don't match are not displayed. Inner join can also be expressed without a where clause using an on. Like for example, the same thing can be written patient ID small occupied by dot ward number ward name. From small occupied by, you can use the keyword inner join. So we are joining two tables. The same example, we just modified this one. Small occupied by table and the small word we join using the inner join. So instead of using comma, the where clause, instead of using the comma, we use the keyword inner join. So instead of using the where clause, we are using another keyword called on. The small word dot word number is equal to small occupied by dot word number. So we have another type. We have seen the inner join. Next we have the natural join. Instead of select star from course C quota Q, where C dot course code is equal to Q dot course code, we can use select star from course C natural join quota Q. So rather than joining the table, you can simply use the keyword natural join to join two tables, because all join tuples names are the same in both tables. Natural join results. See here you can see the result is with a table with 3 rows and 5 columns, course code, title, credit, limit and date reviewed. Note that duplicate columns are automatically eliminated in natural join. But this is not the case of SQL Anywhere. SQL Anywhere differs from the standard query. Select star from course C natural join quota Q will give you this result. So it is giving you course code, title, credit, course code, limit. So it is actually like a Cartesian product. So it's not eliminating, it's not checking the condition. If you want to use a join in a SQL Anywhere, you have to use the inner join. We should use select C star Q dot limit. So we have to specify the name of them. So do not use natural join. If the database is restructured, it may alter the behavior of applications containing natural joins, reduces the maintainability of the database.